Problem 680, valid palindrome 2. To solve this problem, we need to know one concept, and that's two pointers. Two pointers is exactly what it sounds like. You have two pointers that point at various, elements within an array, for example, and you basically do stuff with the pointers as you see fit. In our case, we're trying to validate palindromes, so we'll see how this comes into action as we solve the examples. So basically, we're given a string s, and we want to return true if the string s can be a palindrome after deleting at most one character from it. So let's consider example 2. I think that's the best case. A, B, C, A. A palindrome is where reading it forwards is the same as reading it backwards. So we will have a pointer at the beginning and a pointer at the end, and they will converge towards each other. And we will check the current element that each pointer is pointing towards to make sure that they are equal. And if they're not, we will do stuff with it. So if the elements are equal, like here, then we obviously just move the pointer one by one element to the right and reverse for P2. So A and A are equal, therefore P1 gets shifted to the right by 1 and P2 gets shifted to the left by 1. Now we are considering two elements that are not equal. If they are not equal, then we basically get one freebie in the sense that we get to skip over and delete potentially P2, the element at P2, or we can potentially skip over the element at P1 and not consider it. So basically, we are going to keep evaluating the palindrome like normal. So basically, if we had B and B, we're just going to keep incrementing P1 and P2 like so until we hit a discrepancy. Once we hit a discrepancy, there's no more do-overs, right? We have two choices. The two choices are we either delete the element at P2 or we delete the element at P1. And after we delete this one, we want to check if it's a palindrome. If it is a palindrome, then this is a valid string. We return true. And if it's not, then we turn no, right? This is not good. And the same goes for this case. If it is a palindrome, we obviously return true. If it's not, we return not. So that's the whole logic, and we can program that up in Python. So we're going to need two pointers. P1 is 0, P2 is the length of the string minus 1. And while P1 is less than P2, we're going to check if the element at P1 is the same at P2. If the element at P1 is the same as the element at P2, then P1 just gets incremented by 1, P2 gets decremented by 1. If they're not equal, well, we have two options. We can either delete and skip the element at pointer 2 or the element at pointer 1. Which one do we choose? Well, we don't know. We have to simulate both scenarios. So if we want to simulate that, it would be nice to have a helper function to do that for us. So let's do def valid palindrome 2. And we're going to pass in the string the pointer 1 and pointer 2. And here it's going to be the exact same algorithm, except we don't initialize P1, P2. We have the exact same while loop because it's the exact same checking. While the two pointers are less than each other, we do this. And otherwise, if it doesn't work, then we just return false, right? Because we already used up one freebie. And after that freebie, there's no more tries. We can't delete any more elements, so we return false. And if it comes out of this while loop intact, then we return true. So if else, then we have to return the output of valid palindrome 2, given that we skip over the element at P1, or we skip over the element at P2. So this is what we do, like so. And with that, that should be the whole algorithm, because we know that this has to execute, but just in case, we'll just do return true, because if this all passes, then obviously this should work. Consider ABA. It would never go into an else statement. It will just exit the while loop successfully, so we return true. And that's the whole thing, so let's run it, which should work. So let's submit. And that's the solution.